North Pole is the top of the Earth, and the South Pole is the bottom, of course. Except that the Earth is kind of a ball, and they don't really have tops and bottoms. Granted, the Earth isn't exactly spherical, and it's spinning through space, spinning about an imaginary axis of rotation. One of the points where that axis goes through the Earth, right here in the Arctic Ocean where the Russians planted their flag on the seafloor in 2007, is called the North Pole. Or rather, it's the geographic North Pole, because just like there are different definitions for what a year is, there are different North Poles. For example, compasses don't point to the geographic or spinning top North Pole. They point to the magnetic North Pole, which is incidentally a magnetic South Pole since opposites attract. The magnetic North, actually South Pole, and South, actually North Pole, are an electromagnet caused by swirling convection currents in the Earth's liquid iron outer core. These currents are heavily influenced by the rotation of the Earth, so the magnetic field they generate roughly aligns with the Earth's axis of rotation, but not precisely and not unchangingly. 100 years ago, the magnetic North Pole was located in northern Canada, over 2,000 kilometers south of the geographic North Pole, and it's been moving consistently northwest since then, currently sitting in the middle of the Arctic Ocean 450 kilometers south of the geographic North Pole and drifting about 55 kilometers closer to Russia each year. What's more, the magnetic South Pole is not on the exact opposite side of the Earth from the magnetic North Pole. It drifts around in a somewhat independent fashion and is currently 20 degrees closer to the equator than magnetic north. Such is the nature of magnetic fields generated by confusingly swirly molten iron deep inside the Earth. But if you imagined instead that there were just a giant perfect bar magnet inside the Earth, then that bar magnet would point towards the geomagnetic North Pole, which is currently located in Ellesmere Island, Nunavut, Canada. This pole, together with the geomagnetic South Pole, which is on the exact opposite side of the Earth, represents the general overall trend of the Earth's magnetic field, especially as it extends into space. So while it's not at all useful for compass navigation on the Earth's surface, it does heavily influence the paths of solar wind particles that cause the aurora, that is, the northern lights. Beautiful. In short, the North Pole's whereabouts depend on what you care about. The Earth spins like a top around the geographic North Pole, compasses point to the magnetic North Pole, which is actually a magnetic South Pole, and the northern lights are strongest in a ring around the geomagnetic North Pole, also a magnetic South Pole. All three North Poles move, too. The magnetic and geomagnetic poles change quite drastically, but even the geographic North Pole moves up to 10 meters a year as the Earth wobbles on its axis due to seasonal air pressure differences across the globe, melting ice caps, and so on. Assuming that the Russians planted their flag exactly at the geographic North Pole in August 2007, not once since then has it been exactly at the pole. It was as far as 12 meters away in 2009 and as close as 20 centimeters in 2010. Right now, it's about 3.5 meters away. Basically, the Earth is doing the biggest, slowest pole dance ever around the Russian flag.